Hi, and welcome back. Sometimes the prompting techniques we covered so far do not generate the desired result. In this module, I will expose you to some of the most sophisticated prompting strategies that go beyond the basics, like tree of thoughts, self-consistency, and knowledge generation. These techniques will enhance your ability to generate nuanced and precise responses from AI and equip you with the skills to apply AI more effectively in solving specific business challenges. By the end of this session, you'll have a deeper understanding of how these advanced techniques function and how they can be strategically applied to optimize outcomes in various professional scenarios. The tree of thoughts technique represents a significant evolution in prompting methodologies for large language models, enhancing the traditional chain of thoughts approach. While chain of thoughts prompts a model to generate a sequence of thoughts linearly, tree of thoughts adopts a more sophisticated tree branching strategy. This allows an LLM to explore multiple potential paths simultaneously rather than being confined to a single sequential thought process. By facilitating this branching, tree of thoughts enables the model to consider various solutions or strategies at each decision point, enhancing its ability to handle complex tasks that involve critical initial decisions or require detailed future planning. This advanced prompting technique has proven particularly effective in tasks requiring intricate planning and problem solving. According to the research presented in Tree of Thoughts, Deliberate Problem Solving with Large Language Models by Shunyu Yao and colleagues, Tree of Thoughts has markedly outperformed Chain of Thought in various applications. For instance, when applied to the game of 24, a challenging mathematical puzzle, Tree of Thoughts enabled a GPT-4-based model to improve its success rate dramatically, from 4% with Chain of Thought to 74% with Tree of Thoughts. This evidence highlights its capacity to significantly boost performance in tasks requiring non-trivial planning and creative solution exploration, making it a crucial technique for graduate students specializing in AI and machine learning to master. As the complexity of prompts increases, you should expect to spend more time thinking and writing the prompt. Here are the best practices in writing a Tree of Thoughts prompt. Start by providing a brief contextual background to set the stage for the model by giving it a framework of relevant information that might influence its thought process. Then define the problem clearly or pose the question that needs to be addressed. This clarity helps the model understand the context and goal. List potential initial thoughts or decisions that the model can consider. These serve as the branches for more detailed paths to develop. Instruct the model to consider the consequences of each initial choice, leading to secondary thoughts or actions. This is where the tree begins to form, with each branch representing a different line of reasoning or pathway. When establishing initial choices and encouraging branching, it could be helpful to specify the expected depth or type of analysis for each branch. This ensures that each path not only diverges in direction, but also aligns with the depth of detail required for the problem at hand. Continue to deepen each pathway by adding layers of thought, analysis, or additional choices, mirroring how a decision tree expands. In the branching and deepening stages, encourage the model to consider probabilities or uncertainties associated with each decision or outcome. This reflects more realistic decision-making processes and can lead to more nuanced understanding and solutions. Conclude the prompt by asking the model to either summarize the insights from each branch or select the most suitable solution based on the analysis. If the platform allows, making the prompt interactive by allowing iterative feedback could further refine the outputs. After the model presents initial branches, you could review and ask for deeper analysis on specific branches, mirroring real-world analysis iterations. Let's see an example of Tree of Thoughts prompting. Consider the following problem statement for a city planner of a mid-sized city. Identify and evaluate effective strategies to increase public transportation usage by 30% within the next year in a mid-sized city. Considering the expansion of service areas, improvements in service quality, and implementing targeted marketing campaigns. Analyze each strategy's feasibility, cost efficiency, and potential impacts, and recommend the most viable solution based on a detailed assessment of outcomes. With this problem in place, let's create a prompt using the tree of thoughts technique. The first step is to define the problem and provide a detailed context. I use the problem description provided before to come up with the context and problem definition. Remember, for complex reasoning tasks with a structured approach like the tree of thoughts technique, the use of specific labels like context and problem definition can be very beneficial, as they can enhance the effectiveness of your prompt by creating and organizing the information into clear, digestible sections. This is particularly important for advanced techniques. Here we list potential initial thoughts or decisions the model can consider. These serve as the branches for more detailed paths to develop. As you can see, you can be quite detailed with the set of sub-problems or decisions the model needs to make. The complexity of this problem we are asking the model to solve is quite extraordinary, and thinking that a machine can do this is mind-boggling. Next, we need to instruct the model to consider the consequences of each initial choice, leading to secondary thoughts or actions. This is where the tree begins to form, with each branch representing a different line of reasoning or pathway. Following the listing of initial choices, the prompt explicitly encourages the model to branch out from each initial choice into secondary considerations and deeper analyses. Expand service areas. This branch is developed further by considering logistical challenges, additional infrastructure requirements, and the probability of community support. This not only deepens the branch, but also introduces sub-branches that deal with different aspects of the main strategy. Improve service quality. Here, the branch explores enhancements in service factors like frequency, cleanliness, and punctuality. It also examines the feasibility of these improvements and their probable impact on customer satisfaction, which again broadens the scope of this branch into practical and impact-oriented sub-branches. Marketing and public awareness. This strategy is branched into assessments of different types of campaigns, their potential reach, and their impact based on historical data and demographic analysis. This creates multiple sub-branches focusing on the design and effectiveness of marketing efforts. Moreover, the model is asked to evaluate the probability of community support, adding a layer of complexity that anticipates variable human responses, which are crucial for planning. In this case, I am adding an extra step here that I did not formally introduce. If the platform allows, making the prompt interactive by allowing iterative feedback could further refine the outputs. After the model presents initial branches, you could review and ask for deeper analysis on specific branches, mirroring real-world analysis iterations. The conclusion statement will force the model to summarize the insights from each branch, or select the best solution based on the analysis conducted in each step. You might think that this is quite hard, and it is true. However, given the context and the problem statement, you can ask the large language model to write it for you. As the problem complexity increases, you can see how the prompt becomes more complex as well. Nevertheless, I hope you have enjoyed this advanced technique. Next, I will another variation on the chain of thought prompting technique called self-consistency. Coming up.